Limits involving infinity. This is our second video, which is talking about limits. Now, when we are going to have the simple infinity inserted with a limit, we have two scenarios for that. Either when we're x approaching the number a, whether from left or from right, that the value of your function is going to decrease or increase without any bound. In this case, we say that the line x is equal to a is a vertical asymptote of your function. Or, that is, when x approaching plus or minus infinity, and if your function is going to approach certain value, pi, then we say that the line y is equal to pi is a horizontal asymptote. Let's start with the first part when we are dealing with vertical asymptotes. Now, we have many scenarios that we could work for this one, like the given graph. Now, when you are approaching a from left, you will notice that the curve of your function is going to decrease without any bound. And when we are approaching a from right, that is, the curve of your function is going to increase without any bound. In this case, we could say that the limit when x approaches a from left for f of x is approaches minus infinity, and the limit when x approaching a from right for f of x will approach infinity. In both cases, we said that the limit when x approaching a for f of x does not exist. The other scenario is that your function might increase or decrease without any bound from both directions of your point. Like in the blue curve, y is equal to f of x, you will notice that if we are approaching a from left or from right, then in both cases the curve of your function y is equal to f of x is going to increase without any bound. So that means the limit when x approaching a from left or from right for the function f of x, your function will approach infinity. So the limit when x approaches a for f of x approaches infinity, but still that the limit does not exist. In the other curve, the green curve, you will notice that the function y is equal to g of x, when you are approaching a from left and right, in both directions your function will decrease without any bound. So that means the limit when x approaches a for g of x is going to approach minus infinity. Again, this limit does not exist because infinity is not a number, it's a notation for the growth of your function. Now, what's going to happen if we are approaching a horizontal asymptote? Simply when we are using the notation when x approaches infinity or to minus infinity, it means that we are going in the positive direction of the x-axis or in the negative, far negative in the x-axis. In both cases, if your function is going to approach some certain real numbers, then we say that y is equal to this real number is our horizontal asymptote. From the curve here, y is equal to f of x, you will notice that if on the x-axis, if we go far in the positive direction of your x-axis, you will notice that the curve of your function will approach the line y is equal to b1. And if we are approaching far in the negative direction of your x-axis, you will notice that the curve of your function is going to approach the real line y is equal to b2. So that means the limit when x approaching infinity for f of x will goes to b1, and the limit when x approaches minus infinity for the function f of x, this is going to go to b2. And this is when we are dealing with horizontal asymptotes. So this video is going to give you an overview about limits that's involving infinity, whether we are talking about vertical asymptote or horizontal asymptotes.